All right, so I'm going to make a flowchart to help you sort of bring together bond polarity, molecule polarity, and intermolecular forces. Okay, so the very first question, and we're assuming these are all covalent molecules, right? Because if it has a metal and a nonmetal, it's just ionic and we're done. All right, so the first question I have to ask myself is, are the bonds polar or nonpolar? Okay. And what I'm really looking for here is to see if the bonds are between the same atom or different atoms, right? So if the electronegativity difference is 0, which is usually I have the same atom, usually it's between the same atom, then that means that the bonds are nonpolar. Now, if I have an electronegativity difference, which I'm going to write delta En, that means change in electronegativity, is greater than 0, so I have different atoms, then the bonds are polar. So I'll give an example here. A nonpolar bond would be like hydrogen, hydrogen. A polar bond would be like hydrogen and chlorine. Okay? Now, if the bonds are nonpolar, the molecule must also be nonpolar. Now we know that if we have a nonpolar molecule, the intermolecular forces have to be dispersion forces. And go back and watch the last video if you need help tying those together. Okay? So if I have like HH, for example, it's dispersion forces, done, because the bonds are nonpolar, so the molecule is nonpolar, and I have to have dispersion forces. Now, if the bonds are polar, I then have to ask myself another question. And the question I have to ask myself is, do the dipole moments in the molecule cancel out? Okay. And the easiest way to tell this is if they have a lone pair on the central atom. So if the answer is yes, they cancel out, usually that occurs when there's no lone pair on the central atom. That should be an L, central atom. Okay. In this case, we know we had polar bonds, but if the dipole moments cancel out, the molecule is nonpolar. And if the molecule is nonpolar, we know that the intermolecular forces are dispersion. Now, the other choice is that the answer is no, they don't cancel out. And usually our clue about this is that there's a lone pair on the central atom. So then I know that my bonds are polar and my molecule is polar. But then I have to ask myself another question, which is, do I have hydrogen bonded to nitrogen, oxygen, or fluorine? If the answer is no, I don't have hydrogen bonded to nitrogen, oxygen, or fluorine, then my intermolecular forces are dipole-dipole. If the answer is yes, I do, then my intermolecular forces are hydrogen bonding. So hopefully seeing this all put together will help you kind of go through the process of figuring out the intermolecular forces in a molecule. First thing you have to ask is about the bond polarity. Once I know the bond polarity, if it's nonpolar, I'm done. But if it's polar, I have to figure out the molecule polarity. Once I know the molecule polarity, if it's nonpolar, again, it's dispersion. If it's polar, I have to figure out if I have dipole-dipole forces or hydrogen bonding.